In this video, we're going to focus on the goal I can solve compound inequalities. So let's start with the first big idea, which is, well, what are compound inequalities? If you see the word compound, you should think of like a compound word, like book, bag, or no, that wouldn't count. I was about to say hot pocket. That's how y'all know I'm fat. But anyway, like book bag, you see how there are two words being combined to one word. So let's keep that in mind when we talk about compound inequalities. A compound inequality has two requirements, or like two restrictions on a quantity. So let's just put it like this. Let's say we have the cool club. Now you all know Miss Anderson is cool, so I'm in the cool club. And let's say to be in the cool club, you have to wear glasses, because glasses are cool, and you have to be tall. Okay, so let's say we got candidate number 1, pretty tall and wears glasses. Candidate number 2, he's short and no glasses. And candidate number 3, ooh, I made his head too little. He's short. Oh, I done messed dude up. I'm sorry, dude. Let me fix you up a little bit. Short and with glasses. Okay, so there are two types of compound inequalities. We have and inequalities. An and inequality says you have to wear glasses and be tall to be in the club. So that means only person number 1 would go in there, right? But then you have things called or inequalities, which says you have to wear glasses or be tall. So that would include candidate number 1 and candidate number 3. So let's keep that in mind. So here's an example. Let's say we have x is greater than 3 or x is less than or equal to 0. So let's think about what numbers could be in my club. What about 4? Can 4 be in my club? Well, yeah, because 4 is greater than 3. What about 2? No, maybe what about negative 3? Could negative 3 be in my club? Yeah, because negative 3 is less than 0, so that's cool. What about 2? Can 2 be in the club? No, because 2 is not greater than 3, and 2 is not less than 0. So that's what a compound inequality does. It puts two restrictions on there, okay? So that's an example of an or inequality. Okay, what about an and one? And inequalities usually don't use the word and. It looks kind of like this. It would be negative 3 less than x less than 5. So it doesn't use the word and, but we can put it in there. So what does this part say? X has to be greater than negative 3 and x is less than 5. All right, so let's think about some numbers that can go in there. What about 2? Well, yeah, 2 is greater than negative 3 and 2 is less than 5. So yay, 2 makes it. What about 8? Well, is 8 greater than negative 3? Yeah. But is 8 less than 5? No. So 8 can't make it. So you see what I mean with the and inequality? It has to include both restrictions. Where the or inequality, you could be either or. Okay, so that's that long intro. But let's talk about how to solve these compound inequalities. Guess what? You solve them just like you would normally solve them. So that shouldn't take me too long to show you. Just trying to erase everything here. Okay, so let's jump into some examples. Alright, so this is a good one. 3x minus 30 is less than or equal to negative 45. Or, they'll actually put the word or in there. Negative 6x is minus 21 is greater than or equal to 27. So what do you think we'll do? We're just going to solve them separately. So we'll deal with this side. We'll add 30 to both sides. You get 3x is less than or equal to negative 15. Divide by 3. We get x is less than or equal to negative 5. Then we'll come on this side and solve this side. Negative 6x is greater than or equal to 48. Then we'll go ahead and divide on both sides by negative 6. Since I'm dividing by a negative, my sign has to flip. And I get x is less than or equal to negative 8. And then when you're done, you just put the or on there. Okay? All right, let's do another one. So the ors are pretty easy. You just solve each separately, and when you're done, put an or in between your two solution sets. All right, let's do an and one, because those people don't get as quickly. So 5 is less than 3x plus 4 is less than or equal to 19. All right, looks a little weird. So you have two options here. Okay, you can choose whichever one you want. So the first thing you could do, can you see the two inequalities happening here? There's one on this side and there's one on this side. So we can deal with them together or separately. So let's do it together first. I'm trying to get x alone still. So that means I need to get rid of the 4 and get rid of the 3. I'm going to go ahead by subtracting 4. But I have to subtract 4 on all sides, the middle, the left, and the right, which will give me 1 is less than 3x, which is less than 15. Then I need to get rid of the 3, so I'll divide all sides by 3, leaving me with 1/3 is less than x is less than 5. Not too bad. Looks a little funky, but that's okay. Now, if you didn't understand that, we can also just break it into two parts. So like I said, here's one inequality. So you can just write that like this on this side. And then here's the second inequality. You can just write that like this on this side. And just go ahead and solve for both. All right, like we did here. Then you just got to put it back together. So 1 less than x, then bring that less than or equal to 5 over, like that. See? All right, maybe I'll show you one more like this. Negative 10 less than or equal to negative 4x minus 18 less than or equal to 30. Go ahead and get rid of the 18 by adding it on all sides. 8 is less than or equal to negative 4x less than or equal to 48. Then I have to divide everything by a negative 4. Now since I'm dividing by a negative, we have to do what? Flip the signs. So I get negative 2 is greater than or equal to x greater than or equal to negative 12. And there you go.